everyone, and welcome. Today, we are diving deep into one of the most powerful, most fundamental features in Python, classes. You know, if you've ever wanted to structure your code to model real-world things, like cars or dogs, or maybe even characters in a game, then you've absolutely come to the right place. But before we get into how awesome classes are, let's talk about a very common problem they were designed to solve. So picture this. You're working on a project, things are going great. But as you add more features, you start to get this feeling. You've got dozens of different variables and functions that are all related to the same idea, but they're just kinda scattered all over your code. It's getting messy, it's hard to keep track of, and honestly, it's becoming a real headache to maintain. This is a super common growing pain for developers, so if you've been there, you are not alone. Now, you might be thinking, hey, why can't I just keep using variables and functions? It's worked for me so far. And look, that's a totally fair question. Let's think about a real-world example. Imagine you're trying to represent a car in your code. You'd need its make, its model, its year. Then you'd need functions to make it do things like drive or fill up the tank. In our heads, all of that stuff is connected, right? But in the code, well, they're just floating around as separate pieces. Let's see what that actually looks like. So look at this. On one side, you've got these variables holding the car's details, and on the other, you have these separate functions for its actions. They're related in our minds, but the code has no idea. That drive car function has no real connection to the car make variable. And what if we wanted to manage a second car, or third? We'd have to create a whole new set of car 2 make, car 3 make variables. You can see how this gets out of hand fast. There has to be a better way to bundle all this together. Well, there is a better way, and it's called a class. A class is really the heart of a style of coding called object-oriented programming, or OOP, and it's just a brilliant way to structure your code by bundling all those related properties and behaviors into a single, neat, reusable package. You can think of it like creating your very own custom data type. So what is a class, really? The absolute best way to think about it is as a blueprint. I mean, think about it. A blueprint for a house defines how many bedrooms it has and where the doors go, but it isn't an actual house, right? You can't live in a blueprint. A class works exactly the same way. It's the template that defines what something is and what it can do, but it's not the thing itself. And this image, wow, it just makes it so clear. On the left, you've got the dog class. That's our blueprint. It says that any dog we create will have properties like a color and a height, and it will have actions or methods like sit dot and shake dot. Then on the right, you see an object named Tiny. Tiny is a specific real-life dog created from that blueprint. He's an instance, and he has actual values for those properties. His color is gray, white, and black, and his height is 18 inches. So this is the key takeaway, the most important thing to get. The class is the blueprint, the general idea, the template. It defines the structure. The object is the concrete, usable thing you build from that template. So our car class says all cars have a make and can drive function. But an object, like our Audi_A4, is a real instance with its own data that can actually perform that drive action. All right, enough theory. The best way to really understand this stuff is to get our hands dirty and actually build it. So let's create our car class from scratch, step by step. You're gonna see just how elegantly it solves that whole problem of loose data and functions. And here it is, in all its glory, the simplest class you can possibly write in Python. We use the class keyword, then we give our blueprint a name, in this case, car with a capital C, which is the convention. That pass keyword is just a placeholder. It tells Python, hey, I'm gonna add stuff here later, but for now, just know this blueprint exists. So we have a blueprint, but it's an empty one. Okay, next up, we need a way to actually give our car its specific make and model when we first create it. And for that, Python has this very special method you see here, __init. Those double underscores, by the way, are a clue that it's a special method that Python uses for its own purposes. This is the initializer, or constructor, and it runs automatically every single time you create a new object from this class. Inside this init method is where the real magic starts. We define the object's attributes. These are just variables that belong to each specific object. Now look closely at that line self.make equals make. What we're doing here is taking the make value that was passed in and we're storing it in a brand new variable called make that is attached directly to the object itself. And that little self keyword is the key to this whole operation. So what on earth is self? Well, this quote from Python Crash Course just nails it. Think of it this way. When you create a new car object, Python needs a way to refer to that specific car inside its own blueprint. It automatically passes the newly created object as the very first argument, which, by convention, we always call self. It's how the object gets its own unique data attached to it. And here it is, the moment we've been building up to. We create an actual car object by calling the class name just like a function. The variable myCar is now an instance of the car class. We pass in Audi and A4, and our __init method gets to work, setting up the object's attributes. Then we can access that data using this simple clean dot notation, mycar.make. Look at that, so much cleaner. Okay, so we've successfully bundled our data. That's awesome. But what about the behavior? Remember our original problem? The drive car function was just floating around on its own. While with classes, we can put the functions that belong to an object right inside the blueprint itself. And when a function lives inside a class, we call it a method. This is honestly one of the best ways to think about it. Attributes are the nouns. They describe what the object is or what it has, its make, its model, its color. Methods, on the other hand, are the verbs. They describe what the object can do. It can drive, it can brake, it can honk its horn. They're just functions that live inside the class, all ready to act on the object's specific data. So let's add one to our code. We just define a function, drive, right inside our car class. Now, notice it takes self as its first parameter, just like _init did. This is absolutely crucial because it gives the method access to the object's own attributes. So inside our drive method, we can now use self.make and self.model to print out a custom message. And just like that, the data and the action are finally, truly bundled together. Now, if you thought classes were cool, get ready for their superpower, inheritance. This concept is all about code reusability. Instead of writing every new class from scratch, you can create a new class that inherits all the attributes and methods of an existing one. It's just like a child inheriting traits from a parent. This diagram of chess pieces is a perfect way to visualize it. You could have a general piece class that defines properties common to all pieces, like having a color. Then more specialized classes, like pawn, king, and queen, can just inherit from that piece class. They get the color attribute for free, and then they can go on to add their own unique rules for how they move. And you know what? The syntax in Python for this is so simple, it's beautiful. To create a child class, you just write electric car and then put the parent class, car, right there in parentheses. That one little step immediately gives our electric car everything the car class has. Then, inside our init, that super.init line is how we call the parent's init method to handle setting up the make and model. This is a total game changer because we don't have to rewrite any of that logic. We get to reuse tested working code. And this is where inheritance gets really flexible. So imagine our original car class had a method called fillTank. Well, that doesn't really make sense for an electric car, does it? So our child class, electric car, can define its own version of that fillTank method. This is called overriding. Now, an electric car object will use this new version, while a standard car object would still use the original. The child class can specialize and adapt the parent's behavior to fit its own unique needs. It's just so powerful. All right, we have covered a ton of ground, so let's do a quick recap to lock in these key ideas. A class is the blueprint. An object is the real thing you create from that blueprint. Attributes are the variables an object holds, the nouns. Methods are the actions it can perform, the verbs. And finally, inheritance lets you build new, specialized classes on top of existing ones, which is the cornerstone of writing clean, reusable, and scalable code. By organizing your code into classes, you're not just tidying up your files. You are adopting a powerful new way to think about and structure your programs. You're building these reusable, logical components that can grow with your project. So the only question left is, with this powerful new tool in your hands, what amazing things are you going to build?